David Smith here with one more Flip Classroom math video in the rain. 3 tips before we start. First, you can speed up or slow down the playback if that helps you digest the content. Second, you can pause the video anytime and catch up with your notes. Lastly, you could turn on the captions and watch my words go by on the bottom of the screen. Today's lesson covers applications of trigonometry. And so what we're going to do is we're going to divide these tools into 2 categories: tools that work with right triangles, and then tools that work in a more general way with non-right triangles. Now these tools also work with right triangles, but we can use them on anything. So I want you to pause the video and think about what we've covered in our class and see if you can come up with some items that belong here and things that belong here. So just do a little bit of thinking and then come back. All right, so check this out. Right triangles, SOHCAHTOA trigonometry. This is your primary tool with a right triangle. Just make sure that you remember that you can't use SOHCAHTOA with a non-right triangle. Okay, just remember that. And then I also put the Pythagorean theorem here because it does work with right triangles. It's not trigonometry because it's not using a trigonometric function, but it might provide the bridge between what you know and what you need to find out. So don't forget your a squared plus b squared equals c squared. Moving along, non-right triangles, we have 3 tools that work for them. We have the triangle area formula with sine, we have the sine rule, and we have the cosine rule. These 3 rules and formulas work for any triangle. You don't need a right triangle. They're not SOHCAHTOA, but I think in some ways they're more powerful. And you can use these rules with right triangles if you want. All right, let's do a problem. Now this problem is going to have a bunch of steps. We're going to cover a bunch of things here. So here's the setup. Here's our diagram. It's labeled. You're given some stuff. So you might study that a little bit and go, what could I figure out given what's here? Because you're going to have to do that. So here's our scenario. These are 2 gardens. We've got some wacky gardeners out there that like their triangles and they like weird shapes. So we have this garden and that garden. Okay, so we got PQR and PRS. First question, find the length of the fence between them. Okay, so that would be this line here, PR. Now, I want you to pause the video and figure out which of all those rules on the last board you're going to use to do that. Often these problems, that might be the hardest step. Is this a sine rule problem? Is this an area formula with sine problem? Is this a SOHCAHTOA problem? So pause the video and figure that step out. Okay, let's see how you did. If you noticed that you have an angle and 2 sides that are next to them, that sets you up for the cosine rule to find this side. So then you would do your plug-in step and do the cosine rule. So actually, go ahead, pause the video right now and do that. All right, let's see how you did. So my plug-in step, the most crucial and sometimes the most confusing. So what I remember of my cosine rule is that this side squared is going to equal this side squared plus this side squared minus 2 times this side times the cosine of this angle, which is 30. All right, let's see how you did. So first step is recognizing and using the cosine rule is that the side opposite the angle that you know is the side squared that goes on this side of the equal sign. So I have PR squared. And then I know that it's going to be equal to this side squared plus that side squared minus 2 times this side times that side times the cosine of 30. And that's where we get the name for this rule is cosine rule. So I've got 7 squared plus 12 squared minus 2 times 7 times 12 times cosine 30. Crunch my numbers, crunch it down. Now remember to take the square root to get your final answer. Lots of folks forget that step and they would just say, hey, it's 47.5. If you got there and you did the reasonableness test, you'd realize that there's no way that can be 47.5 if these are 7 and 12. Okay? So that's how that one goes. All right, let's do another problem with this problem. Find the area of PQR. So that's PQR. So go ahead, pause the video, figure out which rule you're going to use to do that. Okay, this one's pretty easy because it's asking for area. We really only have one formula in this chapter that deals with area of a triangle, and that's the area formula with sine. So go ahead and use that formula and calculate that area. I just did my plug-in step here, 1/2 times 7 times 12 times the sine of 30, and I get 21 meters squared. So that's that area. A third question, find angle S. Okay, so let's take a look. That would be this angle up here. So I want you to pause the video, think real hard. What rule are you going to use to find angle S? Okay, if you thought sine rule, you're right. So now, pause the video, write the sine rule equation that would allow you to find angle S, and go ahead and find angle S. All right, so here's my plug-in step. I put my angle on top of the fraction because that's what I'm wanting to isolate. It makes the second step a whole lot easier because really all I had to do is move my 6.89 to the top. So I have sine S equals 6.89 times sine 100 over 13. I take the inverse sine of that pile of calculation, and that's going to give me angle S. I got 31.5. So that's my measurement for angle S. Now, there's something you should do right now. I want you to pause the video and think about that. Okay, I have to check. I used the sine rule to find an angle. I have to make sure that this is not the obtuse version of an obtuse angle that's really my answer. So one way to do that, I can look at my diagram. Does this look like a 31.5 degree angle? Sure does. There's no way this could be obtuse. It has to be small. So that is a correct answer. One more calculation. Of course, I'm always going to give you one more. So check this out. Part D. Find the area of PRS. So that's this triangle here. Go ahead, pause the video. First figure out what formula are you going to use to find that area. Okay, I'm hoping that you came up with the area formula with sine, because we did that already. Area, it's prompting you for area. It means you're going to need that area formula. Okay, so what I want you to do now is pause the video and do that math. All right, let's see how you did. So the area formula requires two sides and the angle between them. And we just didn't have that in this triangle. We had two angles and this side, and we had that side. But with the sides we have, we needed this angle. So that's the route that I took. I knew these two angles, so I could just subtract them from 180 to get 48.5. That's all of this step here. Once I know that angle, then I can just do a plug-in with the triangle area formula. So I've got 1/2 times 13 times 6.89 times the sine of 48.5. And what I get there is 33.5 meters squared. I just want to say a few last things. Remember that these application type problems are always going to be different. You're not going to be able to memorize a certain situation or a certain diagram. You're just not going to be able to do that because there's an infinite number of problems that could be invented, including an infinite number of situations that those problems would lie inside of. So how do you prepare for that? You prepare for that by practicing your critical thinking. So that means that when you get a tough problem, you don't just go, hey, somebody else explain this to me. You stay with it and you try. And if you can't get it, you put it down, go away, come back, pick it back up. The only way you can build critical thinking is to stay in that spot where you can't figure it out and keep trying to figure it out, because that's where those muscles get exercised. So resist the temptation to just go to your study buddy, your pal, your teacher, and just have them just explain how that goes, because that's actually much easier than figuring it out for yourself. So anyway, that's my pep talk for problem solving using trigonometry. Thanks for watching. Just before you go, make sure to write down any questions that you have so that you can bring them to our next class and get them answered. Also, remember that you can watch the video again if you want to deepen your understanding. Finally, if you enjoyed the video, please click like or subscribe.